Yesterday you learned how to use the try and except block in Python. Try and except avoids the program from breaking abruptly for the user with an error. So instead of showing an error to the user, which is not recommended, you give a new opportunity to the user to enter the correct commands. So in our case, if the user entered something like edit do that instead of edit 1 or edit 3, so if they entered edit do that, which is a wrong command to enter, we perform these actions. So we tell the user that the command is not valid, and then we continue the loop. We give the user a new opportunity. So we ask the user to enter the command again. And we check all the cases again freshly. It was important to specify the name of the error here, value error in this case, so we saw that in the command line we got a value error, therefore we specify that in here. And that was what you learned yesterday. Today there's a lot of important things you need to learn, so I'll see you in the next video. Hey, in this video you will learn one of the most important elements of Python, and that is custom functions. So let's look at our code and see how custom functions will improve our program. Because currently we have a problem with the program, and the problem is redundancy. So we have repetitive code in our code base. These two lines here are repeated in here and here as well, and here too. So 4 times we have the same code. There certainly should be a better way not to have to write repetitive code, and the answer is custom functions. So now I'll go ahead and create a custom function, and you'll see how a custom function becomes beneficial in avoiding redundant code. Custom functions are usually created on top of your code, so outside of the loop. So a custom function is like a slot where you put some code and then you just call that custom function. So the slot must have a name, so let's call this get_to_dos. And that's the syntax, that's how you start. So you start with the def keyword and then you specify a name, whatever you like. The rules of naming it are the same as naming variables. So you shouldn't start with a number, you shouldn't have spaces in the name, you can have underscores, that's fine. So that's the first line. In the next line then, you put the code. So in our case, it would be these 2 lines. So I'm going to copy them and paste them in here. But we need indentation. So here you want to paste that code. So make sure it's 4 spaces. 4 spaces is the recommendation. So I have 4 spaces here, 1, 2, 3, 4, and 8 here, 1, 2, 3, 4, 1, 2, 3, 4. So this indentation here is because we have this with context manager, and this indentation here is part of the function. Make some space. It is recommended to have 2 spaces between a function and other parts of the code. So 2 break lines. So that's the code that is repetitive. We put it in a function, and then we want to add another line at the end which starts with return. So return is a statement, just like we have other keywords. So this is also a keyword. So return to dos. So that there is the function definition. Once you have defined the function, then you can remove these lines and replace them with the function call. So that's like the other functions we have been working on, like you see open, input, print. So this also has the same syntax. Now it doesn't get any argument. You'll see how to create functions which also get arguments. For this lecture, let's focus on functions which don't get any arguments. So this getToDo's function will return something, right? And that is the list. Now we need to store that into a variable. The variable is normally this one, ToDo's. So we store that list in that variable there, and then we append ToDo's to that variable. And we can do the same in the other parts of the code. So ToDo's is equal to getToDo's. So wherever you have this function in read mode, right? Don't confuse it with write mode. We will work on that later. That's not the same code, correct? We should be clear about that. So here is another open function with the read mode. ToDo's is equal to getToDo's with parentheses. Don't forget the parentheses because that is a function call. And the last one, ToDo's, is equal to getToDo's. And that's it. So let's run the code to make sure it's working. Let's add a ToDo. Make soup. Make pizza, enter, show, and everything seems to be working fine. So we tried the show condition where we have this function and everything is working fine. So you know that we had these built-in functions in Python such as open and input. So I've been referring to these as functions, but these are actually function calls. So here we call the function. The function itself is written somewhere else. So just like here, this is not the function, this is the function call. The function itself is written in here. So that's the instructions on what this function does. Now, where are these functions written? Well, if you are on PyCharm, you can right click here and you can go to and go to implementations. If you are in another IDE, then just watch the video. You don't have to perform the same. So just see what I'll explain here. So by going there, this will take you to the function definition for the input function. So again, we can try another function, such as open, right click, go to implementations. It takes you again to the definition of the open function. If I press this asterisk, it will expand the definition. So this is just comments, this is not code, it's the description of the function, which is actually what you get when you do help open in the command line. So if you do help open, you actually see the same description. And that is referred to as a docstring. So it's the documentation of the function. And then down here you have pass. So you don't actually see the code here, you only see this docstring and pass. And that is because all these functions, so open and input, these were written in C language. So C is the language used to write the interpreter of Python. You remember when we installed the interpreter from python.org? That is a program which interprets Python language, and that program is written in C language. So all these functions are actually written in C language and we cannot see the code. You'd ask, well, what is this then? Well, this is just a fake representation of the function, and this is done by PyCharm. So other IDEs may not offer this feature, so this is not so much useful. Just wanted to show you that these are actually written somewhere. In this case it's in C language. You'll see that other functions which we'll use later in the course are written in Python actually, but not these main functions. So let's close the console. And next I want to talk about variable scope, to be exact. So if I was to open a new Python file here, just give it a name, whatever you like, and create a new function such as greet. This function has a variable which has a value, let's say hello, and then maybe another variable, new message equal to message dot capitalize, and then return new message. Meanwhile, I would like to right click here and keep our program open here on the right, so maybe you want to see that too, to compare the functions. So both functions have a def keyword and a return statement as well. The syntax is the same. They both have a variable declaration in the body. This one has two variables here, here and here. So now I can call this function. Let's say greeting is equal to greet, and then print out greeting. And we need to make one more break line there for being consistent with recommendations of style, and run the code. Yeah, run test, and that's the output, hello with capital H. So what happened is that when the function is called, then this is returned. And what is the value of that? Well, so here message gets this hello string, and then the value of new message will be hello with H capitalized, and so the function returns hello capitalized. Therefore, the value of this is going to be hello, and that value is stored in the variable greeting here, and then we print out that value, so we get hello. So far so good. What happens though if we print new message? And this is where we talk about variable scope. So if we run this program, we're gonna get an error. It says name error, name new message is not defined. How comes, since we defined it here? Well, that's because this variable is only valid inside the greet function, so its scope is local. That's why you cannot access that variable from here. You'd ask, why is that? Well, let's take an example. Let's say you go to a cafe and you go to the bartender and you order a coffee. You just say, I want a coffee, so these words are the function call. You just called a function. The function itself is the process of making the coffee. So the code of the function, the elements of the function definition are maybe coffee beans, is the machine, the water, the interactions between all these. And it's not a good idea for you as a client to have access to these elements which make up the function, the coffee process. So the function is the coffee making process. So all you get as a client is the coffee. That's what we get also from this return statement. So the return statement makes available only one variable, the output variable that you want the function to produce. In our coffee example, that would be the actual coffee cup with the coffee inside, so that's the output. Likewise, you cannot access the message variable, so every variable in here is not accessible. So you can only access what is returned, and you can access it by calling the function, not by referring to the variable name itself. That's an internal name inside the process. Now back to our app, we see I have this underline here, and this is saying that this name shadows to-dos from outer scope. Outer scope is the variables which are declared outside functions. So in this program here, that would be, for example, greeting. This is a variable in the outer scope of the program. So the problem here in our app, which is not a problem actually, it's a recommendation, but we can fix it. The thing is that we have this variable with this name here, and it's not a good idea to have this variable with the same name. So what we can do is we can change the name to this variable. Let's say to-dos local. And then of course here, be careful, you have to return that same variable, right? And so now what we have is we create the local variable in here, which will hold this list from to-dos, and then we return the value of that. Therefore now this other variable, which is not a local variable, it's a global variable. So the opposite of local is global. So this variable now will be equal to the value that this variable produces in the function here. We have the same problem with file, so this is also complaining that we have another variable, a global variable with a name file, so we can convert this to local as well and also reflect that here. So be careful, file local here, file local there. So that's the final code. Let's fix this complaint as well. I can reformat the file, and that will add a new break line. So as I said, it's good to have two break lines between functions and other parts of the code. So thanks a lot for following this, and I hope it makes sense. We will be using functions over and over again throughout the course, so let's keep going. Hey, let's run a few code experiments now for a better understanding of functions. Specifically, you want to understand the difference between function definitions and function calls. And that is what the first experiment is about, the difference between function calls and definitions. So if I remove all these calls here and I just leave the function there and I run the code, nothing will be returned as an output. Well, you could say there's no print function here, that's why we didn't get any outputs. But I can provide a print function here. Let's say, hey, hey, and I run the code, again, no output. So why is that? Well, that's because this is just a recipe of the process. If we wanted to use our coffee making example again, so when you go to order a coffee in a bar and you go to the bartender and you ask them, I want a coffee, they have a recipe in mind, maybe in their mind, maybe they have written it somewhere. So the recipe is the function definition, that's the function definition. The recipe itself has to be executed by someone, the bartender. So the function also has to be executed in order to get the output. and we execute the function like this. So greet. So that's the variable and that's the value. So at this point, this will be equal to hello with the first letter capitalized. But if we run this again, what we get is hey hey. So the function was called, and that proves it. We get hey hey. So the function was called because this was executed. That's how we know the function was called. We don't get hello printed out because we simply got hello and we stored it in greeting. So if we want hello to be printed out, we say print greeting. You run again the code and then you get hey hey and also hello. So it's very important to realize that the function call is equal to a value. The value of that is always whatever is returned in here. So it could be a string, it could be a number, it could be any object that the function returns. So I hope that helps you understand the difference between the function definition and the function call. Now the next experiment. It is about the return statement. So try to remove that line and print out the code. This is what we get this time. Hey hey and none. So again, the interpreter goes and executes the blueprint. It doesn't do anything. It just looks at the recipe. And then you execute the recipe here. But the problem is that this time the recipe has not instructed what to return. So the coffee was prepared, but the recipe didn't say, oh, give that coffee to the client. And when that doesn't happen, implicitly the function definition will return a none object. So just like we have integers, strings, we also have this special object called none. None is basically to represent a nothing. So in Python you can actually, in the console you can just say none, so that's recognized as a value. So it's not a string, it doesn't have quotes, so this would be different from that. That is a string, that is a special object. So that here is equivalent of having return none. If we run this, we're gonna get the same error. Hey hey, sorry, the same outputs, it's not an error. The same hey hey and none. So you normally want to return something here. In this case is new message. Some people, what they will do, especially beginners, they will confuse print with return. So instead of returning something, they will say print new message. And let's see what we get this time. So this is what happens. The interpreter reads the recipe and then it executes the recipe. So message is associated to the hello string, and then new message is associated to hello with the first letter capitalized. So far so good. Then print hey, so this is printed out in here. Then print message. Message is printed out, hello. You see with the letter capitalized, so far so good. And then none is printed out. Why is none printed out? Well, because I just told you that when you don't have that return statement, the function will always return none. So implicitly the function again is doing return none. That's why we get none here. So in other words, greet will be equal to none, to that object. And that's why when you print here, we are printing the none object, the object that the function greet returns. So you don't want to confuse print with return. Always try to return the output instead of printing it out. So if I run the script now, we get the correct expected output. Hey, hey, printed out by this, and hello by that. So why is it important to return and not print? Well, because perhaps you want to do something to that value, which is hello. Perhaps you want to print out the length of hello. So the length would be len greeting. You run this and you get 5. But if you had print here, see what you get now? It's an error because you're trying to apply len to none, to the non-type object. And that gives an error because the non-object doesn't have a length, doesn't have characters like a string has or a list has. So again, I cannot stress it enough that you should return instead of printing. So this was about functions for this code experiments for today. Thanks a lot. See you. Welcome to today's bonus example. In this session, we will be creating a function which gets some numbers from a text file and returns the average of those numbers. So please create an empty Python file and in the same directory with your file, create a files directory. So files and bonus11.py are in the same directory. Inside files, please create a text file, so just a file with the name data.txt. And there you can write temperatures and just write some dummy values like that. So that is our data file and we want to calculate the average of those numbers. And this is our file, text file. So I'll have these data.txt files split on the right so I can see both my codes and the data, just for convenience. Let's start to write the function. As you know, we start to define it with def keyword and give a name to the function. Usually I like to name functions with a get, so that when I call them down here, I can write a variable which represents the returned value of that function. So the name average makes sense. And now this is like the process. So I'll get the average from that process. So the naming makes sense, I think. Right, get average. First of all, we want to get the content of that file. Here you want to be careful with the file path. So bonus11 is in the same directory with files. Therefore, we can say files here, and then slash, and then data.txt. We want to open that file in read mode as file and read the data with file.read lines. So since we are interested to get all these as separate values, then we think about using read lines instead of read. Read would give us that entire text as one single string, but this will give us that as a list of strings. So with that, I can unindent so that the file is open and then it's closed. So at this point I have the data in here, I don't need to work on the file anymore. So I unindent, but I'm still indented under the function definition. Everything is inside the function definition body. So if I return the data at this point, just to test things out, and then I print the average. Average at this point is just a list, so let's check it out. Run bonus11. Yeah, that's what we get. So it's good to take things step by step, see the output, and then try to improve it. Especially when you are a beginner, you don't want to get overwhelmed by just writing a long list of code lines and then you check the output and something doesn't work and then it's hard to pinpoint the exact error. So my suggestion is to create values as we did here, check it out if the value is correctly stored and so on. So now we can go ahead and do the next step, which is to remove this item. So that is the header of the text file, right? And so we want to calculate the average on the numbers, but this is a problem. So how do we remove that? Well, you could apply here list slicing. So that is a list, right? That is a list, therefore this syntax makes sense. So that is the equivalent of doing 1, 2, 3, and then you get, for example, you get from 1 to the end of the list, and that will give you only 2 and 3. So the item with index 0, which is this item here, is excluded from the list. Only the item with index 1, which is declared in here, so only the item with index 1 and everything after that is included in the slice. We can do the same in here, 1, like that, run the codes, and yeah, now we get only the numbers. But I would suggest you not to do that slicing in there, but you exit the file operations and just create a new variable. So values is equal to data, and then you extract the values from the data and then return values here and you get the same output. So there you have an intermediate variable. It's better to have intermediate variables because it helps you debug your programs easier. So you know that at this step you're simply reading the data, and then at this step you are slicing them. So that is better than doing everything in one line, reading and slicing. Better to have everything separated. Next, you see that these are strings, so we need them as numbers. How do we modify all the items of a list? Try to think about that. Well, using a list comprehension. You say float I for I in values. So every item will be the float representation of itself for all the items in values. So that is the existing list, and we use the same variable to store the new list in that existing variable. So we update the value of that variable. The new value will be the updated list. Run the script. And there we have a list of numbers. I didn't use int here because these are continuous values. Even though none of them is a decimal number, I know that these are temperatures. And with temperatures, theoretically you could have 5.1, so you could have decimal numbers. Therefore, it makes sense to use a float data type to represent these values. So now we have a list, and next we calculate the average. The average is the sum divided by the number of items. So the sum of the numbers divided by the amount of numbers we have. We can get the sum using the sum function. It's a built-in function, and it gets a list as input. So the list in our case is values, and we divide the sum by the length of values. In other words, this would be like we make the sum of them, which is 34, and then we divide that by 4, and that gives us the average. And then we return the average here. we do have this underline. It says that this shadows the name average from the outer scope. So we can change this to average local, but it's better to change it if you are on PyCharm. It's better to right click here, go to refactor, go to rename, and say average local, and that will change all the occurrences of that variable in the code. So you see that PyCharm knows that this is a local variable, so it will change the local variable within the function. It does not change that global variable there. So press enter, and there you have it. So that's a local variable, it's returned in here. Then we get that return value, we store it in this global variable, and we print that out, that value. So run this, and that's the average of those values. So that's a neat function to get the values from a text file and give you the output. Thanks for following this, and I'll talk to you later. Hey, in this video I want to compare Python with other programming languages such as Java, C++, etc. So Python and these other programming languages are all high-level programming languages. So let's look at an example here. We have two pieces of code, this one here and this one in here. They both do the same thing, but they are written in different languages. This one here, as you can tell, is in Python, so it's very concise. All we have to do is write the print function and then followed by the string in parentheses. And that will print out that text in the command line. Now this code here does exactly the same thing, but this is written in Java. So as you can tell now, Java compared to Python is written in more lines of code. And actually this is one of the main differences between Python and other programming languages. So Python is very concise, and that has made it one of the best programming languages. Now you might say, well, does Java have any advantages? Well, yes, it does. Generally, programs written in Java tend to run faster. However, nowadays, with computers getting more and more powerful, that is becoming a difference which is less important than it was before. Now, another difference is that Java is a statically typed language and Python is a dynamically typed language. What that means is that a variable you declare in Java is associated with a type. For example, it could be associated with a type of string or an integer type, and you cannot change that during the course of the program. But in Python, once you write a variable x is equal to 1, you can reassign that variable. For example, in the next line you can say x is equal to hello, the hello string. So you're changing the type of variables. And also another difference is that Python is an interpreted language and Java or C++ are compiled languages, which means that once you write Java code, you first need to translate it into machine code using a compiler, and then that is run to give you the output. But Python is run on the fly by the interpreter, and this is also related to the fact that compiled languages are faster, so Java tends to run faster compared to Python. However, Python is best used for web development and data science, and Java excels in things like graphical user interfaces on desktop, so desktop apps, or mobile apps. So Python is not so good in mobile apps or desktop apps. So if you're after web development, data science, automating things, then Python is the best way to go. So with that, I think I gave you a general idea of where Python stands compared to other programming languages. So thanks for following. See you later.